Srinivas working as an assistant professor in IARE. Today we will learn the entity relation diagrams in DBMS. In this session, you will learn what is an ER model, history of ER models, what is ER diagram, why use ER diagrams, the components of ER diagrams, what is the relationship, what is weak entities, attributes, cardinality, ER diagram notation, steps to create an ERD, best practices for developing effective ER diagram. Okay, let us get started with what is history of what is ER model. ER is nothing but entity relation model. Is a high level conceptual data model diagram. ER modeling helps you to analyze the data requirements systematically to produce a well-designed database. The entity relation model represents real-world entities and the relationship between them. It is considered a best practice to complete ER modeling before implementing your database. ER modeling helps you to analyze data requirements systematically to produce a well-designed database. So it is considered a best practice to complete the ER modeling before implementing a database. Suppose you want to implement a project. So before actually designing the database, first you have to see how the entities are each related to each other. After making a good design, then your database would be a well designed and it will be well working database. It will not have any errors. So we'll have to analyze requirements very carefully before you start actually creating tables and etc. Okay. History of ER models. The ER diagrams are a visual tools which is helpful to represent the ER model. It is proposed by Peter Chin in 1971 to create a uniform convention which can be used for relational database and networks. He aimed to use an ER model that is made as a conceptual modeling approach. This is the history of an ER models. Entity relation diagram, ERD. ERD helps displays the relationships of entity sets shown in the database. In other words, we can say an ER diagram helps you to explain the logical structure of the database. At first look, an ER diagram looks like very similar to a flow chart. However, the ER diagram includes many specialized symbols and its meaning makes this model unique. The purpose of ER diagram is to represent the entity's framework structure. So here, apparel size is one entity, product is one entity, and product category, colors, all these are different entities. Okay. And these entities are interrelated to each other. Like for example, apparel size is related to product. Product is linked to product categories. Again, the product color. Okay, we represent the actual flow, the business logic of the system in this ERD diagram. Okay, it first establish various entities and what are its attributes. The apparel size has a size ID, size code, size sort order as an attributes. Okay. Now facts about ER model diagram. ER model allows you to draw database design. Okay. Based upon this ER diagram, you can create the various tables required. Okay. It is easy to use graphical tool for modeling data. Widely used in database design. It is a GUI representation of the logical structure of the database. It helps you to identify the entities which exist in a system and the relationship between those entities. Like these two are two entities, and we can establish a relation between these two. This same thing we will implement while designing the database. Okay, it helps you to identify the entities which exist in the system and the relationship between those entities. Okay, why we use ER diagrams? Here are the prime reasons for using an ER diagram. Helps you to define terms related to entity relation modeling. Provides a preview of how your tables would connect, what fields are going to be in each table. Helps you to describe entities, attributes, and relationships. And attributes are nothing but the properties of the entities. ER diagrams are translatable into relational tables, which allows you to build database quickly. Once your diagram is ready, you can quickly start designing the tables. Okay, ER diagrams can be used by database designers as a blueprint for implementing data in a specific software solutions. The database designer gains a better understanding of the information to be contained in this table in the database with an ERP diagram. The ERD is allowed you to communicate with the logical structure of the database to users. Okay. Now we'll see what are the various components of ER diagram. This model is based upon three basic concepts. One is attribute, one is the entities, which is high level, then its corresponding attributes and how these are related. For example, in a university database, we might have entities for students, courses, and lecturers. Student entity can have attributes like roll number, name, and department ID. See, entities are nothing but the properties of an entity. The student ID can have attributes like roll number, name, and department ID. They might have relationship with courses and lecturers. Here, entity name is the car, is the university. Okay, the attributes name would be like the properties of the entities. For example, the color of the car entity, the name of the student entity. And there's also called as relationships. It is work phase, the association between the instance of one or more entity types. For example, blue car belongs to a student Jack. See, that is how it is. How we relate the attributes to entity is the relationship. Okay. Now, what is entity? A real world thing, either living or non-living, that is easily recognizable and non-recognizable. It is anything in the enterprise that is to be represented in our database. It may be a physical thing or a simpler fact about the enterprise or an event that happens in the real world. An entity can be place, person, object, event, or a concept which stores the data in the database. The characteristics of entity are must have an attribute and a unique key. For example, every entity is made of some attributes which represent identity. For example, person is an entity. Place is entity. Object, event, concept. All these are examples of an entity. Okay. Person, employee is an entity. Student is an entity. Patient is an entity. See, example, it is anything which is recognizable and non-recognizable. A person is a recognizable. Place is recognizable. Object is recognizable. Event is non-recognizable. Where concept is like your account, course. So everything which is easily recognizable, not recognizable is a real world entity. This is entity. Now we'll see what is entity set. An entity set is a group of similar kind of entities. A group of similar kind of entities are known as entity set. It may contain entities with an attribute sharing similar values. Entities are represented by their properties, which is also called as attributes. And entities are represented by their properties. See, every entity will have properties. That is nothing but attributes. All attributes have the separate values. For example, a student entity may have name, age, class as attributes. So, student is an entity having various properties such as name, age, class, sex, is roll number. All these belong to the student entity. For example, the class will have an attribute. The class strength is one attribute. Class strength is one. Class course is one. Okay, class professor, class lecturer. All these are attributes. Then an example of an entity is that a university may have several departments. All these departments employ various lecturers and offer several programs. Some courses make up each program. Okay, student registered in a particular program and enroll in various courses. A lecturer from the specific department takes each course, and each lecturer teaches various groups of students. Okay, this is an entity set. Yes, what is We have seen what is an entity. We have seen what is an attribute. We'll see what is a relationship. The relationship is nothing but an association among two or more entities. For example, Tom works in a chemistry department. See, Tom is working with a Tom is from a assume it is a lecturer entity. The subject is one entity having the one of the subject is chemistry. Tom is working in chemistry. These two can be linked using the association. The entities take part in relationships. We can often identify relationship with verb or verb phases. For example, you are attending this lecture. I am giving the lecture. Just like entities, we can classify relationship according to the relation types. A student attend a lecturer is giving a lecture. This is the relationship. Now, what are weak entities? A weak entity is a type of entities which do not have its key attribute. It can be identified uniquely by considering the primary key of another entity. For that, weak entity set needs to have participation. An entity not having a key attribute is nothing but a weak entity. But it can be identified when it is part of some relationship with other entity. For example, here the ATM. ATM has three properties: ATM ID, address, and time. Okay, and there is one more thing called transaction is one more entity. Trans number, amount, and type. In example, trans number is a discriminator which within a group of transaction in an entity. Okay, here ATM is linked with transaction, and a transaction number is the discriminator within the group of transaction within ATM. Now let us learn about a weak entity by comparing with a strong entity. Strong entity versus a weak entity. Strong entity can set always has a primary key. In weak set, it does not have enough attribute to build a primary key. There is no such key attribute available in the weak entity to make it as a primary key. It is represented by a rectangle symbol. The entity would be represented by a rectangle symbol. It is the weak entity is represented by a double rectangle symbol. Okay. Strong entity contains a primary key which is represented by the underline symbol, whereas in weak it contains a partial key which is represented by dashed underline symbols, whereas the strong is represented by an underline symbol, but this is represented by dashed underline symbol. The member of a strong entity set is called as dominant entity set. A member of strong entity set is called as dominant entity set. The member of a weak entity set as subordinate entity set. Primary key is one of its attributes which helps to identify its member. Primary key is a key which is used to uniquely identify a record in the database. So here it is the one of the attribute which helps to identify its member. In a weak entity set, it is combination of primary key and partial key of a strong entity set. And it's seen in the example earlier, ATM and transaction. That is a weak relationship. Only when it is combined with an ATM ID, your transaction number would become a value to be, it can be discriminated. Okay. In the ER diagram, the relationship between two strong entities is represented by diamond symbol, rhombus, diamond. Okay, diamond. Okay, the relationship between one strong and one weak entity is shown by double diamond symbol. The connecting lines of strong entity set with the relationship is single. Yeah? When you want to connect a strong entity set, it is a single line, whereas it is here double line here. Okay. Now attribute. We'll see what is attribute. Attribute is a single valid property of either entity type or relation type. For example, a lecture might have attributes like time, date, duration, place, etc. an attribute is represented by an ellipse. So ellipse. Okay, this is all attributes. Okay? Transaction is a weak entity set because it is in the double rectangle. Okay, attribute is represented by an ellipse. Okay, now we'll see the types of attributes. Simple attribute. A simple attribute cannot be divided further. For example, a student contact number is also called as an atomic value. Okay, which cannot be divided further is a simple attribute, and for example, it is a student contact number. Composite attribute. It is possible to break down composite attribute. For example, a student full name may be further divided into first name, last name, and second name. So when it can be further break down, that attribute can be called as a composite attribute. Let us see what is an derived attribute. This type of attribute does not include in the physical database. However, the values are derived from other attributes present in the data. For example, the age should not be stored in the data directly. However, it can be derived from the date of birth of that employee. You don't, because age is always continuously changing by year. So we will not store that directly in database. However, we'll store his date of birth whenever we want to age. We can compare with current date and can display it as that is nothing but a derived attribute. Now, what is a multi-valued attribute? Multi-valued attributes can have more than one value. For example, a student can have more than one mobile number, email address, etc. This is multi-valued attribute. Now we'll see what is cardinality. Cardinality defines the numerical attributes of the relation between two entities or two entity sets. The different types of cardinal relations are one-to-one relations, one-to-many, many-to-one, many-to-many. Okay, when it is mandatory one, this is how we represent it. We represent it like this. When it is mandatory many, this is how. An optional one is like this. An optional many is like this. These are all entities. Okay, these are the entities. This is how they are. These are the relationships. And if it is mandatory one, like this symbol. If it is mandatory many, it is represented by this, like this. We'll say one-to-one. One-to-one. One entity from entity X can be associated with at most one entity of entity Y and vice versa. For example, a student can register for numerous courses. However, all those courses have a single line back to the student. A student can be enrolled in many courses. Okay, many courses. However, all the courses have a single line back to the student. Okay, this is one-to-one. One-to-many. One entity from entity set can be associated with multiple entities of entity set. But an entity from entity Y can be associated with at least one entity. For example, one class is consisted of many students. So many students can be in one class. Class will have many students. Okay, this is one-to-many. Now see many-to-one. More than one entity from entity X can be associated with most one entity of entity set Y. However, an entity from entity set Y may or may not be associated with more than one entity of entity set. For example, many students belong to the same class. Many students belong to the same class, but not all students belong to the same class. Okay. Many. One entity from X can be associated with more than one entity from Y and vice versa. One entity from X can be associated with more than one entity of Y and vice versa. For example, student as a group are associated with multiple faculty members, and faculty members can be associated with multiple students. Students as a group, like for example, per project will have multiple faculty members. Same way, the faculty members will be associated with multiple students. This is many-to-many. Next, we'll see what is ER diagram notation. We already have seen that the rectangle is nothing but is represented by an entity type. The ellipse is for the The ellipse is for the attributes. The diamonds represent the relationships. The lines are the how these are linked to each other. Okay, which is nothing but the relationships. Primary key attributes are underlined. Okay, and crossed lines are weak entities. Double ellipsis means represents multi-valued attributes. So if entity is strong, weak will be in two rectangles. An attribute is nothing but a rhombus. Multi-valued will be in what double ellipse. The strong relation will be like a rhombus, whereas the weak relation will be double lined rhombus. Now, let us see steps to create an ERD diagram. The following are the steps to create an ERD diagram. First, we have to identify the entity. Then next step will be to identify the relationship. Next is the cardinality identification. Identify attributes. Create ERD. Now let us study with an example. In a university, a student enrolls in a course. A student must be assigned to at least one or more courses. Each course is taught by a single professor. To maintain instruction quality, a professor can deliver only one course. Okay. Here totally in a university, a student can enroll courses. The student can be assigned to one or more courses, and each course is taught by a single teacher, single professor. Okay, now we have here three entities. One is student entity, one is the course, one is the professor entity. Okay, we have three entities. Now first we have finished the identity of entities. Okay. Next, we'll see how these are related. We have the following relationships. A student is assigned a course, professor delivers a course. So we have two entities here, the student and course, and a student is assigned to a course and professor will deliver the course. Okay, these two are the two entities, and these are like one is assigned here, one is this one deliver. These two are we have identified the relationships. Next, cardinality identification. For them, the problem statement, we can know that a student can be assigned multiple courses. A professor can deliver only one course. A student can be assigned to multiple courses. Okay, fine. And as a logic, as a business logic, we have said that a professor will deliver only one lecture, only one course. This is we have identified the cardinality identification. Next, we have to identify the attributes. You need to study the files, forms, and reports and data correctly maintained by the organization to identify the attributes. You can also conduct interviews with various stakeholders to identify entities. Initially, it is important to identify the entities without mapping them to a particular entity. Once you have the list of attributes, you need to map them to an identified entity to ensure that an attribute is to be paired with exactly one entity. If you think an attribute should belong to more than one entity, you use a modifier to make it unique. Once the mapping is done, identify the primary keys. If a unique key is not readily, we'll create one. Now, example, now we have three entities called student, professor, and course. Now here we have student ID is one and one entity. Student name is one attribute. These two attributes. So we have made the student ID as primary key, but because it will uniquely identify the record. Same way, the employee ID, professor name, course ID, course name. By this, we have identified the primary keys. Now, the student ID is the primary key for the student attribute, and the student name is one more attribute. Similarly, course ID, course name, course ID is the primary key. The course student is assigned to a course. The professor will take a class, will deliver. Okay. The professor ID is employee ID is the primary key. Okay. The second attribute for a professor is professor name. Now steps to create a more modern representation of ER diagram would be like this. Student having two attributes, student ID, student name is assigned to course ID, course name, and professor will deliver the course. Now, the best practices for developing effective ER diagrams. Eliminate any redundant entities or relationships. You need to make sure that all the entities are. You need to make sure that all your entities and relationships are properly labeled. There may be various valid approaches to an ER diagram. You need to make sure that ER diagram supports all the data you need to store. You should assure that each entity only appears single time in a ER diagram. Name every relationship, entity, and attributes are represented by a diagram. Never connect relation to each other. Should use colors to highlight important portion of the ER diagram. Summary of the ER diagrams. ER model is a high-level data model diagram. ER diagrams are visually tools helpful to represent the ER model. The entity relationship diagram displays the relationships of entities stored in the database. ER diagrams helps you to define the terms related to entity relation modeling. ER model is based upon three basic concepts: entities, attributes, and relationships. An entity can be a place, person, object, event, concept which stores data in the database. The relationship is nothing but an association among two or more entities. A weak entity is a type of entity which does not have its key attribute. It is a single valid property of either an entity type or a relation type. It helps you to define the numerical attributes of the relationship between two entities or entity set. ER diagram is a visual representation of the data that describes how data is related to each other. While drawing ER diagram, you need to make sure that all your entities or relations are properly linked. With this, you complete the ER diagram in DBMS. Thank you. Have a good day.
Like, share, and subscribe. Hit the bell icon for more updates.